All right, so let's cap off our understanding of number systems with a few examples. So what I have here are, this is basically, if you take a look at this, this large box outside here represents the real number system, and that's why I wrote R here. This small circle here represents n, so the natural numbers. Within that is the integers. And then within this rectangle here, the smaller rectangle, that represents q, which obviously we know as the rational numbers. And this other smaller rectangle over here represents the irrational numbers. And once again, together, they form the real number system. So our goal here is to take all these numbers, these 5 numbers, and input them correctly into the correct spaces as shown in this sort of Venn diagram. So let's do them step by step. So this is exactly how we understand our real number system. So this really should be easy. So the number 1, we know it's an integer, but really it's also a natural number. So it's going to go right here. So I'm going to put the number 1 there. I'm going to cross that off over there. And the reason why I can't go here, because this space right here represents all the integers that are not natural numbers. So this space right here, which I'm sort of moving over, that represents all the integers that are not natural numbers. So in other words, -2, -3, 0, as we said before. Okay, next. So 2/3. We know 2/3 is a rational number. It's not an integer, so it can't be inside this big circle. So it has to be here. So 2/3 is going to be here. Anywhere. You could have written anywhere as long as it's within the rational frame. And then I'm going to cancel that out. So -3, we know that's an integer, but not a natural number. So it has to be in this space over here. So I'm going to cancel that out. Pi over 4, as we said before, it looks like a rational number, but pi is not rational. So therefore, it's an irrational number. So pi over 4 would go here. So we're going to cross that out. And then -e², obviously that's irrational as well. So that's going to go right here. And so we're done. We've put all these 5 numbers into their appropriate spots according to this Venn diagram. All right, so let me do another example. I'm going to use the same 5 numbers, but I'm going to show you a different Venn diagram. So make sure you sort of copy this down. So what it is instead of what we had before, now this larger box, this larger rectangle represents all of the rational numbers. And within that is, here are the natural numbers, and they intersect with the integers over here. So this circle represents the integers, this circle represents the natural numbers, and they're both inside this larger frame, which is of the rational numbers. All right, so before we start putting these numbers into the appropriate places in this Venn diagram, what we have to do is realize that some things don't really make sense. So for example, I'm just going to use green. So for example, we know that all the natural numbers have to be embedded inside the integers. So there cannot be any natural number that is not inside the integers. So therefore, this space right here, this entire space right here, does not make any sense whatsoever. No number can ever go inside here, because we know that this entire circle, or all the numbers in this entire circle, must be inside the integers. And since this is outside of that, obviously there's no number even exists over here. And everything else makes sense. And over here, what this means is, here are natural numbers that happen to be integers, but we already know that all natural numbers are integers. So now that we've sort of taken care of that, the rest will fall into place. So I'm going to use blue again. So number 1, we know that's natural. It's not an integer. It can't be here because this represents a space of negative integers. So this is over there. 2/3 is a rational number. It can't be anywhere inside the integer set. So I'm going to write 2/3 here. And I could have written 2/3 here. I could have written 2/3 here. It doesn't matter as long as it's within this sort of rational set. So I'm going to take that out. -3, obviously it's not natural, but it is an integer. So it's going to be right there. Right? Pi over 4. Again, we said that this is an irrational number. So if this box represents all the rational numbers, the irrational numbers have to be outside of it. So you can write pi over 4 anywhere as long as it's outside of this box. So we're going to strike that out. And finally, -e². Well, that's also irrational, so I'm going to write that over here because it's outside of the rational box. So there we go. We have basically placed all the numbers in their appropriate places in this Venn diagram. Okay, now let's do something a tad bit harder. I'm going to just scroll down just a bit. Again, those 5 numbers, and let me just show you this. Make sure you copy this down. So it's just, again, those 5 numbers. And what we see now is we have 3 circles. We have this circle representing rational numbers, this circle representing natural numbers, and this circle representing integers. So let's see how, before you put anything, you want to disqualify spaces that don't make sense. So as we know, so let's take, for example, these two. So we know all the natural numbers have to be inside the integer set. So this entire circle has to be inside that. So anything outside of that does not make sense. So if we can see, if we just consider these 2 circles, well, all of this doesn't make sense. All of this space does not make any sense whatsoever, because all the natural numbers have to be inside the rational numbers. All the natural numbers have to be inside the integers. Now let's look between these 2 circles. And so we have the integers and we have the rational numbers, and we know that all the integers are inside the rational numbers. So therefore, anything outside the rational numbers does not make sense. So all this space makes no sense whatsoever. Makes no sense whatsoever, because all the integers have to be inside over there. And now we're done, right? And if we look at these 2, all the natural numbers have to be inside here, and of course this space is natural, and it is inside the rational numbers, and we've disqualified everything else. So now what we can do is we can put these numbers into their appropriate places. So let's do that. So number 1, we know it's natural, so it has to go here. Okay, so I'm going to strike that out. There's 2/3. We know it's rational, so it can't go in this space because that's the integer set, so it has to be here. Okay, so I'm going to strike that out. -3, we know that's an integer. So since we know that's an integer, and it's not natural, has to go here. Okay. This is pi over 4, can't be anywhere inside this rational part. So as long as it's outside, we're happy. It has to be outside, and obviously can't be in any of these. So we're done with that. And finally, -e². Well, again, it can't be inside the rational number set, so it's going to be -e². And there we go. So we're now done with this example of how to place all these numbers in their appropriate places in the Venn diagram. All right, I'll see you in the next video.